Translating algebraic expressions. Earlier we worked on evaluating expressions. We learned that evaluate means to find the value. An expression is a group of symbols that represent a value. Some of these symbols are numbers, letters, and operators such as the addition and subtraction, multiplication, and division signs. Today we're going to look at translating expressions. Translating in math is like translating from one language to another. In the examples I will provide in this lesson, we will take English phrases and translate them into algebraic expressions. Before we start translating, let's look at some key vocabulary that will guide us through the process. The words than, from, or to, these are called turnaround words. These are words that tell us to change the order of the expression. We will see how to do this in just a minute. Alright, let's take a look at our notes. Back in elementary school, we learned that certain words or phrases told us what type of operation to perform. Up here we see addition. Here are some of the key words that tell us when to perform addition. Right here we see subtraction and those key words that belong with subtraction. Multiplication, its keywords. Division, keywords. Powers like exponents, squared, cubed, or something to another power right here. And quantities, that's the sum or the difference. Alright, let's look at the English phrases now. We're going to look at this top section in addition. Alright, let's look at this first phrase. It says 8 more than W. First thing I notice, more than, it tells me to add. And then I see the turnaround word than, so that means I'm going to take the 8 and the W and they're going to kind of swap places with the addition. So first thing I want to write is W plus 8. Okay, right here, x added to 9. I see the word added to, obviously I'm going to use addition. And I also see the turnaround word to. So I'm going to take the x and the 9 and I'm going to switch places. So when I write this out, it's going to be x is going to be added to the number 9. So it's 9 plus x. Alright, take this one out. And we're going to do the next one. So here we're looking at the sum of z and 5. So keyword is sum, that tells me to add. I see of, that's kind of like a phrase that says I'm going to group the next two things together. So the sum of z and 5, that means I'm going to add those two things together. So that would just be z plus 5. Okay, alright, let's go ahead and take this out. Alright, the next one, we see the total of R and Z, or R and S. R and S, it's just telling us to add it together, saying the total of those two things. So we would write that as R plus S. Okay. Okay, the next one here, let me get this one out of the way. The next one here, we have x increased by 7. Increased means to add again. So we're just going to write x and it's increased by 7. Alright, let's go ahead and move down to the subtraction ones now. So first thing we're going to look at is 12 less than b. Less than means to subtract, and when I'm looking at this I see that turnaround than, so that means the 12 and the b are going to be turned around. Okay, so let's go ahead and write this up. It's going to be b minus 12, right? Because we had to switch places because of the turnaround word. Okay, the next one, the difference of x and 1. So difference means to subtract again, and I don't see any turnarounds in here, so we're just going to keep it in the order that it's in. So when I write this, we're going to take the difference of x and 1. So it's x minus 1. Okay. Now we're going to look at z minus 7. Minus, obviously, subtract, and there's no turnaround word, so it's just literally taking z minus 7. Okay, next one. R subtracted from 18. Subtracted, obviously we're going to use subtraction here. And I see that turnaround word from. So that means we're going to take the R and the 18 and we're going to switch places with it. Okay, so let's write 18 minus r. So right here it says r subtracted from 18. So here's the 18, and we're going to subtract r from it. Okay. Now, last one for the subtraction that we have here. 17 decreased by a. Decreased means to subtract as well. I don't see any turnaround words here, so we're just going to do it in the order that we see it. So 17 decreased by a. Alright, now we're going to work in the multiplication section. Right here I see 2 times c. Alright, so first in algebra, we don't use the x anymore to show multiplication, so I would not write 2xc. In algebra, the x we use that as a variable, so when we see that, we don't think multiplication anymore, so we're just going to act like that doesn't count anymore. In algebra, you may have seen it also like this, 2.c. We don't really use that much in algebra either, so the way that we prefer to write it is going to be with the number and the letter touching. Anytime you see a number and a letter touching in algebra, that means to multiply them, or if it's two letters up against each other, we multiply as well. So if I was to read this, this would be 2 times c. Okay, let's take that out. Alright, so we're going to look at the next one, and we have the product of x and y. Product is a key word for multiplication, and we have of x and y, so that's a phrase that goes together, so we're going to put the x and y together, and we're going to find the product of those two things. So let's write x, y, right? So they're touching each other, so that shows us multiplication. Alright, so let's get this taken out. Alright, the next one we're going to look at is the 3 multiplied by n. Okay, so we're going to write that as 3 multiplied by n, or 3n is another way to say that. Alright, in this next one, we have 3/4 of m. So we're going to write that as 3/4 m. We're going to show multiplication there. Okay. The next one we're going to have is twice d. So twice d tells us to multiply 2 times d. So let's write that as 2d. That's twice d. Alright, next one is double p. So double p is going to be, double means to multiply something times 2. So we would write that one as 2p. Next one, triple c. Triple means to multiply by 3. So 3c. Next one, we're going to look at is quadruple k. Quadruple means multiply times 4. So we would write that as 4k. Something I didn't mention earlier was that in algebra, we like to put the number in front of the letter when we're showing multiplication. The number is called a coefficient, and the letter is the variable. So we always multiply a coefficient times a variable. Alright, let's go ahead and drop down into the division section now. And in this first one, we see v divided by 15. So we're going to write this in the order we see it. So it's v divided by 15. The next one says the quotient of y and 3. Quotient's another word for division, and we have the phrase the of is a grouping, so we're going to take the y and the 3 and we're going to group those together and use division. So the quotient of y and 3 would look like y divided by 3. Okay, the next one says the ratio of x to 7. So if I was going to write this out, I'd write x to 7. So this line here also shows division. Alright, the last one here in the division, half of k. So the way I could write this would be I would take k and divide it by 2, right? I'm cutting it in half. Alright, let's look at this next section, the powers. First one, it says x squared, so that means we're going to take x and multiply it times itself. That's what squared tells us to do. So if I'm going to write this to show that, I would take the letter x, we're going to call that our base, and then we're going to raise it to the second power, which is our exponent. So this is x raised to the second power, or we say x squared. This next one, we have z cubed. Cubed is to the third power, so we would take z as our base, and we would cube it, or raise it to the third power. So we write a little 3 kind of up and above the z. Alright, and this last one, it says y to the fifth power. Y is our base, and we're going to raise it to the fifth power. Alright, in this bottom section, down here we're going to look at the quantities. So let's go ahead and look at this phrase. This phrase is telling me 3 times the sum of x and 5. I see 2 different types of operations in here. I see times, tells me multiplication, and sum tells me addition. So what's being multiplied and added together? So when I look at sum, the sum of, the of is kind of like a grouping symbol, so I would use parentheses around the x and 5. So I'm going to find the sum of x and 5 first, and then I'm going to multiply it times 3. So the way we would write that would be, I would take the x plus 5, and I would put it in parentheses, right? I'm grouping those together, and then I'm going to do 3 times that. Anytime I have a number outside of a parentheses and there's no operation between it, so right here we see 3 pushed up against a parentheses, that means I'm going to take 3 and multiply it by whatever is done inside of this parentheses. Okay, this next one, we have half of the difference of x and y. So half is telling me I'm going to divide something by 2 or multiply it by 1/2. And I see difference, which tells me to subtract. So I have the difference of something. So that means I'm going to have a phrase coming up and set in parentheses. So it's x and y are going to be inside of a set of parentheses. And then I'm going to take half of that. So let me go ahead and write that down. X minus y. Oops. Let me fix that. We have x minus y. Okay, inside of parentheses. And then I'm going to multiply it by 1/2. Okay. Another way we could have written this would have been x minus y divided by 2. So we could take half of it.